Analyses of historical climate data and climate model simulations around a massive irrigation project in the East African Sahel suggest that irrigation has reduced rainfall over the irrigated area but enhanced rainfall in the surrounding region. These findings further suggest that altered rainfall patterns must be considered during the planning of large agricultural projects, particularly in regions with limited water. In the present study, researchers examined rainfall patterns around Sudan's Gezira Scheme, the second largest irrigation scheme in Africa. In the Gezira Scheme, water is drawn from the Blue Nile to irrigate crops over an area of nearly 9,000 square kilometers. First, the researchers simulated the effects of irrigation on regional climate in the Gezira area from 1979 to 2008 using a regional climate model. This simulation showed increased rainfall east of the irrigated region in the rainiest months of the summer, and reduced rainfall within the irrigated zone. For comparison with the modeled results, the researchers evaluated historical ground-based and satellite-derived data for rainfall, air temperature, and streamflow in Sudan, Eritrea, and Ethiopia from before and after a period of rapid irrigation development at Gezira in the 1960s. The measurements suggest that large-scale intensive irrigation is responsible for a number of effects on the local climate. In the season when crops are watered, the Gezira region becomes notably cooler than the surrounding area, producing a region of anomalous sinking air, higher than average air pressure, and sustained clockwise air circulation, which are associated with decreased rainfall over the irrigated zone. Outside the Gezira region, the circulating air interacts with existing wind patterns to produce increased vertical airflow to the south and east of the irrigation zone, stimulating rainfall over nearby parts of Sudan, Eritrea, and Ethiopia. This change in rainfall is also evident through the increased water volume along the Nile tributaries in the areas that receive increased rain. Together, the historical values and model results provide strong evidence that irrigation in the semi-arid Sahel alters local rainfall patterns, with potentially significant consequences for agriculture. Decreases in local rainfall caused by irrigation mean that greater amounts of water have to be withdrawn during the growing season, challenging the sustainability of the region's water supplies. However, increased rainfall in outlying areas may improve crop growth and support the development of agriculture. For example, the development of irrigated agriculture in Gezira coincided with the emergence of nearby Gedaref as the most important rain-fed agricultural area in Sudan. These results strengthen our understanding of the impacts of land use change on climate at regional scales, and suggest that far-ranging effects must be considered for the planning of large-scale irrigation in semi-arid regions.